Hello, everybody, and welcome to today's presentation, Inserting Business Logic Security Checks into DevOps Pipelines, brought to you by Shift Left. I'd like to introduce you to our presenter, Chetan Kaneki. Chetan is a serial entrepreneur with over 20 years of experience in authoring and architecting mission-critical software. His expertise includes building web-scale distributed infrastructure, personalization algorithms, complex event processing, fraud detection, and prevention in investment and retail banking domains. He was most recently Chief Data Officer at GM Operations at Cloud Physics. Prior to Cloud Physics, he was part of early founding teams at CashEdge, Business Signatures, and Endforce.
First of all, thank you, Billy. Thanks for that introduction, and good morning, good afternoon, good evening to all my attendees. Thank you for taking the time to listen on this presentation. As Billy indicated, my name is Chetan Kaneki, and I'm the founder and CTO at an application security company called as Shift Left. So our topic for today's presentation is inserting business logic security checks into DevOps pipeline. So let us start this presentation by asking a rhetorical question. Do criminals on your website behave differently from typical customers? It's a fairly interesting question because in certain cases, they behave differently. In certain cases, they almost seem like your customer. In a web application, there are three essential security properties that should be preserved. And those are input validity, because you have web routes or RESTful interfaces that accept inputs from your customers, and in certain cases, attackers as well. The other is state integrity, because every time you serve your customers, there is some state persisted, and you have integrity checks to ensure that state conditions are met as per your needs. And finally, logic correctness. As you architecture microservices and monolithic applications, you define constraints to ensure both it performs at that load and behaves in a certain way, which is spec'd out as per your architecture. The failure of web applications in meeting any one of these three properties is the root cause of vulnerabilities that would eventually lead to successful exploitation. While a significant amount of research, solutions, and attention have been given to code-based and syntax-based attacks on web applications, such as SQL injection, cross-site scripting, deserialization, etc., there exists another class of attacks not easy to categorize or classify and can be seen as more of an art. These attacks have been referred to as business logic attacks, which we'll speak about in greater length. As a great number of business processes move into web-based technologies, web applications have become the primary system for affecting business processes over the internet. Business logic attacks abuse the ability of these web applications to manage important functions like user interaction and application state and performance. As business processes are specific to particular organizations, such attacks are also peculiar to their specific targets. Business logic attacks are becoming a more serious issue in web application as they're deeply tied to the company's business process. And in order to combat these attacks, it is imperative to understand the complexity of the logic flaws that exist in those applications serving your business needs. Business logic flaws often escape security scanners, web application firewalls, and intrusion detection systems, because all of us as stewards of our organizations have procured these products over a period of time to improve the security posture of the entire organization. So let's start with security scanners, as they are squarely focused on pattern-based vulnerability discovery, mostly influenced by untrusted input. And this untrusted input is typically induced by adversarial or malicious entities who are attackers. This means that when you're analyzing a certain type of vulnerability, you're looking for certain type of symptoms and patterns associated to that vulnerability that materializes as a consequence of this untrusted input traversing through your application. But when we talk about application logic vulnerabilities or business logic vulnerabilities, they are not patterns. Now let us shift our attention to WAFs. While I don't doubt that WAFs can help stop some types of business logic attacks, I hesitate to accept that it's a good return on investment once you cross a certain level of effort. Not only do you have to heavily customize your WAF for each application it's protecting, you also have to potentially reconfigure the WAF anytime those applications change. In essence, it becomes yet another piece of software that is configured within the WAF that has to be continuously developed and reconfigured in parallel with your applications. And lastly, intrusion detection systems completely lack context of the application and cannot effectively differentiate between a legitimate user and a business logic abuser. So let us draw a line in sand as we need to understand the key differences in perspective of what is and what is not a business logic flaw. So if I have to read out these salient points on the slide, a business logic flaw is not a code-based flaw. It is not malicious behavior of the application. It is not about what code is written. And lastly, it's not about what an application does with the input, meaning it's not always influenced by the input. So shifting our attention to what is a business logic flaw, it is a logic-based flaw specific to your business line. You might be operating in different business lines like fintech, financial, banking, medical or healthcare, etc. So each of that flaw is very specific to that business line. And it's also a legitimate business workflow used in a malicious way, meaning someone has figured out a way to subvert and circumvent that flow in order to trigger an abuse pattern. And a business logic flaw is about how a code workflow is defined and written. And finally, it's about how an input triggers a sequence of actions in your business workflow, which is prescribed by your architecture. As we mentioned before, the most important thing when you're looking for an application logic flaw is to understand how the application works. To do so, it is essential to know the application's flow in its entirety. Most of the application's functionality could be discovered by navigating through the application. Of course, all of our customers navigate through our applications as they log in to serve their specific business needs. For this reason, an attacker commonly uses tools like spidering or techniques like spidering in order to navigate and conduct what they call as a discovery process. And the basic idea of spidering is to extract all links, internal or external, from a request and response perspective in order to discover sections of your application, which is represented by entry points, other communication paths, and hidden resources. Specifically for application logic bugs, it is necessary to put effort into following special zones where there are more interactions. So as we architecture applications, typically they're comprised of several microservices working in unison with each other, and they're fronted with web forms. And in these web forms, there are various other business workflows like user registration, user login, password recovery, etc. And as users interact with the application from a perspective of those functions that I just spoke of, we create tokens, hashes, and then begin to share information between various applications internally. And in certain cases, we provide web services for our customers to interact with. So typically from an attacker perspective, after they conduct this exercise of discovery, which essentially is mapping out your entire application, the next affirmative step is to intercept and circumvent these flows to identify and see what exactly influences the next step or subsequent steps in the flow. So as they conduct this process, the most critical part from their perspective, which is the attacker's perspective, is to intercept them. And there are different points of interception. One is user input based, where if you have a web form, in the discovery process, there is an attempt to identify how a certain value in the web form is influencing the next step. And then thereafter, there's outbound communication channels. That is, identify how an application internally is using services to fulfill workflow conditions. For example, you might have eventing services, meaning if a consumer is fulfilling a certain transaction on your website, you could have an email service that essentially sends an email to the customer to acknowledge that the transaction is fulfilled. Or perhaps an SMS service that is enabling two-factor auth or some degree of notifications. And then there could be internal third-party services, SaaS services, which your applications are using, where you are communicating with Google Analytics or Omniture in order to track your customers' frequency, behavior, etc. And last but not least, you have naming conventions. If you're doing alpha beta testing, you might have certain naming conventions that you use pertinent to a certain test that you're conducting, or perhaps if an exception is thrown, there could be a naming convention associated with the database or the web service. Now, all of this becomes queues because if you have an exception which is reflected back on the browser, an attacker can identify what type of database are you using. Is it MySQL, Oracle, etc.? So it's imperative and important to identify what is reflected back, because it becomes cues for an attacker to take affirmative action on the next steps. So let us guide our thinking with a few use cases. Let's start with a very common use case that happened not too long ago with an online auctioning system. Typically an online auctioning system entails someone to participate in a real-time bid and then conduct bidding in order to buy a product. And like any Dutch auctioning system, the person with the highest bid wins in real time within the scope of that bidding process. So if a hacker or an attacker decides to participate in this bidding process, he could effectively circumvent that process to make it benefit his cause. So let us walk through the series of steps to understand how he could circumvent that process. An hacker could register as a legitimate user and then participate in a real-time bidding process. And assume for some reason you as an engineer or a business owner display all the active bidders on that particular web page. So all the participants get real-time feeds of who's participating, who's bidding, etc. And for some reason, assume that the username could be the email address itself of that participant, which is reflected on that web page. So if this attacker decides to circumvent or game the system, what he effectively could do is harvest out that usernames and then conduct a series of brute force login attempts using that username, which is reflected on that page, which you essentially serve to that attacker. And as a consequence, you might have a business workflow that after a series of attempts of mislogins would lead to locking out the account. And as a consequence of locking out the account, it would lead to invalidation of active sessions associated with that account. So as a consequence, your legitimate users might be thrown out from that active real-time bidding process, which would lead for this malicious entity or this hacker to win the bid because he's the only participant. He potentially participated at the lowest bidding price, so he walks out winning the bid. Now let us shift and look at another use case of an abuse. This happened not too long ago again, where Apple's partnership program enabled a third-party repairman to take onus of repairing iPods adhering to service warranties. So this Apple warranty repair program allowed customers to receive replacement units before the original non-functional music player is returned. But what someone who essentially wanted to return their device had to do is punch in their serial number of that non-functional unit, a valid credit card, and a shipping address. Because with that serial number, it's acknowledged that they own that unit, and the credit card and the shipping address validated their existence, which would lead for Apple to ship this new device. So this repairman or partner figured out how to guess iPod serial numbers based on a certain formatting algorithm. Because this formatting or algorithm essentially contained the highest significant bits to be a predictable sequence, and a certain set of numbers after the prefix described the type of the unit, followed by the color of the unit. So in a sense, as he figured out, he could guess what the subsequent serial numbers could be. So given that he figured out the algorithm, the next step was buy a series of stored valued Visa gift cards in order to satisfy this $1 pre-authorization that Apple conducts just to validate identity. And as a consequence, Apple essentially shipped 9,000 iPod Shuffle units to this repairman, who effectively took these devices and sold it in the second market. So this again is an example of a series of flaws when connected led for this individual to exploit and abuse the return function. So let us now look at a different use case. This use case is very, very common across different business domains, where if you're operating either in fintech or healthcare, every time we fulfill a certain transaction, which is in some degree of information exchange between the participant and the business, we send forth an email to acknowledge confirmation or completion of that transaction. So that email is dispatched with a link. Link often contains like order status and any other subsequent information pertinent to that business, which would lead for that individual to click that link and avail necessary detail. In real cases that we'll speak of shortly, that link directly provided necessary detail with sensitive information without redirecting that user to validate his or her identity. The other issue was, often we store transactional information in databases. Those transactional information can be identified using a primary key ID, which we often store in databases, which is indexed, so we can look up that data. So imagine this sequential primary key ID reflected back to the user, either as an order ID or transaction ID. Even worse, that detail is not authenticated, which would lead for a user to effectively guess what the next ID might be and subvert and look at details of other customers who exist as tenants in your business. This squarely leads to different types of business logic flaws like account takeover, leak of sensitive information, etc., etc. So just to guide you with some real use cases, with Flickr, numeric IDs for email invites were used, like what we see as a screenshot, which was declared as a on HackerOne. The Hacker 1533 is the HackerOne ID, where the Flickr resend invite contained an enumerable and sequential ID, which essentially led for a spammer to continue to guess what the next ID might be and spam a particular user with resend on invites. Here's another use case with Twitter. Twitter has ad campaigns, so they have a particular portal called as ads.twitter.com. And this portal lets a business create ads and target users on Twitter. So again, this was an HackerOne responsible disclosure where credit card IDs, which was essentially IDs stored in the database mapping to credit card numbers, were leaked in the clear, which enabled someone to enumerate and guess what the next number might be, which essentially disclosed sensitive information pertinent to that particular business registrant on ads.twitter.com. Here's another one with Square. Again, carrying the same symptoms of lack of authentication and insecure object reference. So the word insecure object reference, which is titled on the slide, actually means that you're carrying something sensitive from your database, reflecting it either in a URI or in a post request or in a cookie perhaps. And that's a sequential ID which anyone can guess and conduct a cross-tenancy attack. And lastly, here's another case with Zapier, where the log history, because Zapier is a workflow-based system, and each workflow triggered has log history associated with that particular consumer. And again, a sequential ID was made available on a URL as a part of the GET request that enables anyone to guess what the next sequence might be, leading to information disclosure. So all of these cases that we spoke of carry some degree of common patterns. One that we spoke of was insecure object reference. The other was disclosure of information, etc. And they don't look like common technical vulnerabilities because they enabled someone to exploit a certain business flaw that existed in the application, which was essentially inadvertently coded by the engineer. So switching context, I'd like to introduce a product called as Ocular. Ocular is an investigative tool for security analysts, AppSec teams, and developers that provides powerful querying capabilities to identify business logic flaws specific to your domain. Now, as you interact and investigate to ask questions over your code using Ocular, you will get answers and insights. So as good citizens, what we like to do is take those questions, convert them to policies, so that these policies are evaluated on every application that we are releasing in our business domain in order to check for existence of such flaws across various set of applications. And of course, as we derive these insights, we'd like to take these insights and move it to places where our engineers live, which is Jira, GitHub, etc., so that they have enough information to remediate, triage, and resolve those issues. So what I'd like to do now is buckle up and navigate using a simple code snippet, which is represented in an application that contains various types of business logic flaws. So you get a flavor of what Ocular provides as benefits to you as a security analyst, a pen tester, and a red teamer or blue teamer. So I'm quickly going to switch context into my command line prompt, where you will see me interacting with Ocular. The first step that we're going to do is take one such application into consideration that is fraught with different types of business logic vulnerabilities, and then use Ocular to ask questions and identify how we can resolve for them. This application is called as Tarpit, and it's available on the moniker github.com CONIKEEC/TARPIT. So this is a Java-based application. So the first step that we're going to conduct is create a package. Of course, if this being a Java-based web application, often when we create a deployable package, it manifests either as a WAR file, a JAR file, or as an EAR file, which is nothing but a compressed archive that we can take and deploy into our production unit to serve our customers' business needs. Given that we have created the WAR file, the next step that we will do is convert that WAR file into a proprietary graphical representation of the code, which becomes the input for Ocular. This graphical representation of your application or source code is called as code property graph. This is an invention of our chief scientist, Dr. Fabian Yamaguchi, which essentially takes your application, its open source dependencies, the framework upon which it is deployed, and create one large dense graph. This graph is a connected graph that connects your application code to the open source it consumes and the framework upon which it is deployed. And the advantage of having this large graph is you can begin to ask questions which are security relevant upon your source code and get or extract those insights thereafter. So we have created this graph, and the next step that I'm going to do is spin up an Ocular prompt. Ocular is a command line tool that we provide, which is a software distribution that you can install in your data center. It is an on-prem distribution, and there are different ways that you can deploy Ocular. In this demo, we're going to examine how Ocular can be started and in interaction mode, which is an advanced mode. And then we'll also briefly touch on how it can be integrated into your CI as well in autonomous mode so that you can evaluate for security insights. So the Ocular prompt is started with a simple command, Ocular. And if you're familiar with Oracle's PL SQL or any database interactive system, it is very similar to that ilk, meaning this prompt lets you load that graph that we just created and begin to ask questions which are security relevant, almost like a search engine over that graph, and get insights of whether you're violating a particular security constraint or not. So the first step is to load the graph that we just created. So using a command load CPG, I am going to load the graph in the context of my investigation. Now, given that I loaded the graph, I can begin to ask some interesting questions pertinent to your application. So here is an API which essentially says, give me all the types that are defined in this application. And these types could be user-defined types or open source defined types as well, which the application is dependent on. So with this simple API, you get a list of types, and assume that you set a certain mandate that you shouldn't be using a certain type within the entire organization. You can use this API to filter upon, identify if anyone is using that type, and then perhaps fail the build in your CI/CD process. So I'm just going to take this API forward and say, rather than giving me the list, filter and let me know if this application is using zip4j, because this a certain version of this library zip4j is vulnerable to a certain condition called as path traversal. So obviously when I ask this question, it is imperative that this application is using zip4j, because it returned the results, which implies that it's depending on it and to a certain extent using it. So let's go one step further and ask a different question. All of us are creating messages in our application so that we reflect that messages back to our customers. So here's a simple API that says, give me all literals, hard-coded literals defined in your application. So if I click through this and call for this API, I get a series of hard-coded strings, which are fairly interesting. But what is even more dangerous here is I see hard-coded AWS properties. I see a hard-coded SQL string, which is almost puts me on the path of a SQL injection situation. But this is bad. But let's kind of get down and narrow down on perhaps identifying if this code contains any hard-coded credentials, specifically AWS secrets or AWS access keys. So I take that same API, expand it, but I'm applying a filter saying, find me something that matches a pattern of an AWS secret. Lo and behold, I did get a match. The match indicates that a AWS key has been hard-coded, which is not good. But I'd like to go one step further and say, where is it hard-coded? Which method, which file, which line number? So again, I take that API and expand it further and say, give me the method full name at where this particular AWS access key is hard-coded. So now I get the entire fully resolved package name and the method at which this particular AWS key is hard-coded. So let's quickly traverse the code, head to this file, which is io.shiftleft.servlet-tarpit. And lo and behold, the AWS access key and secret key has been hard-coded. So imagine if you have a plethora of code bases and such mistakes are committed in any one of those code bases. Rather than have a human eye lint at it during your code reviews, you can have an autonomous system ask these questions and yield answers. Now, if like all of us, I presume that we are all using software composition analysis. So using a single command, I can ask a question to identify all open source dependencies and their associated versions pertinent and used in this application's context. Again, I get this with a single command, unlike which you have to go and procure another software tool to avail that feature. But let's go one step further and ask if any of these dependencies actually have CVEs associated to them, which is the dependent version pair. Again, using a very simple API, get CVEs on the graph. We provide a web service which gives you any CVEs and NVDs associated with the particular software dependency and its version. What is even more interesting is we provide you an additional set of information of whether you are just not depending on the library, but are you actually even using it? Because often engineers add a dependency to the manifest, but they most likely might not use it. So if there is a vulnerability, you're not at the urgency of going and remediating for it because you might not have the necessary symptoms that could lead for an attacker to exploit that vulnerability. So using this output, you very quickly can identify how to sort, order, and prioritize what needs to be fixed. In this case with JAS-YPT, of course, there is a CVE, but it is not imported and used whatsoever in your application. So you might not treat it as something that you want to triage and resolve for in the immediate next few days. But in certain cases, you might have a library that is imported and actually is used. So in that case, you can use this data point to go and sort, order, prioritize, and resolve for that condition. So here's another interesting API that I want to draw your attention to. I would assume that your organization conducts pen testing on any application prior to it being deployed in production. So typical pen testing encompasses your red team to first enumerate your application to identify all of the entry points or API endpoints in your application. Thereafter, they can use that information to conduct attacks on your application to figure out if it contains vulnerabilities. The enumeration process typically takes between a few hours, that's 6 to 7 hours to a few days, depending on the tool that they're using. We provide a very, very simple API again, where we extract, literally in one command, we extract all the API endpoints in your application. We also associate the type of vulnerability that lies on that API's entry point and the attack vector or the input that can be triggered on the entry point in order to lead for that vulnerability to be exploited. Now, this piece of information is really interesting because it, first of all, optimizes the time your pen testers are spending, because they can use this data to conduct targeted attacks on your infrastructure to validate if these vulnerabilities can be exploited. Even better, if you have a web application firewall you can import this data and configure your rules autonomously to ensure that you're conducting coarse-grained protection at the endpoint or the edge. So there's several such APIs. We merely scratched the surface here. These convenience APIs provide you the facility to more effectively protect your system. So let us switch into some specific use cases here. Firstly, I'd like to draw your attention to one such use case, which is called as cookie poisoning. Cookie poisoning is often an abuse use case, both from a technical vulnerability and a business logic flaw perspective. This vulnerability, the main purpose of cookies are to identify a consumer and possibly customize the experience of your consumer on that web portal that you own. So there are typically three problems if you look at this code base and this code path. And these problem areas have been highlighted in pink, and I'll touch on each one of them. The first one is that sensitive information like user information or user or login information is being added in clear text to the cookie. So now a malicious user can effectively sniff and identify the sensitive piece of information when it's persisted on your machine. The second problem is the fact that the developer did not set HTTP only attribute. So if the browser supports it, in fact, most of the modern browsers do, it will not allow the user to change the value of the cookie. So an attacker, in effect, could effectively override this value and use a non-browser entity to conduct this attack. And the third and possible problem is the fact that the developer did not set the secure attribute. So developers usually store all sorts of information in cookies. Because cookies are easily manipulated, they can exchange information from the server to browser and vice versa. The difficulty of finding vulnerability in this process lies on the fact that the use of cookies is usually intertwined among several program statements. So based on these conditions, what we'd like to first of all check is the cookie initialized? And are you setting an HTTP and a set secure flag? And eventually, after the cookie is set, is a certain sensitive element set and redirected back to the browser. So I'm going to quickly illustrate. I'm going to switch back to the browser, to the console of Ocular, and ask these questions. So note that in the world of Ocular, every question asked is asked from a perspective of, is information starting at the source? Is it touching a sensitive sink like a file system, a database, a memory unit? And then what is the reachability between the source and the sink? Meaning, what are the criteria that you've set? Are you doing any sorts of a control flow check, like an if-then statement? Or are you, in this case, conducting a check like set HTTP only or set secure? So as I execute the script, Ocular provides in the console a pretty printed representation of the entire flow sequence. So using this flow sequence, you can actually identify if is a set HTTP only or set secure actually being set from the point of inception, which is the source, to the point where a sink is touched, which is the file system or cookie persistence, etc. So it is evident here that max age is set and there is no set secure or set HTTP only. I'll proceed to ask the next question. That is, after the cookie is initialized, are we forwarding that information to a certain web page? And lo and behold, yes, we are. So it means that with all evidence based on these two flow patterns, this particular code snippet is susceptible to cookie poisoning. And using cookie poisoning, an attacker can effectively circumvent a certain business flow. I'll draw your attention to another use case. We spoke of several use cases of what we call as indirect object reference and lack of authentication. As I described, the case in point of Square, Flickr, Zapier, they all had the same symptom. In a sense, they provided a web route or an API RESTful interface that enables someone to look up an order or a transaction, and that lookup did not redirect to validate if that user actually owns that particular transaction. And even worse, it reflected back the primary key from the database. So it carried two symptoms. One is lack of authentication, the other is indirect object reference. And how can we query all of your REST interfaces in all of your applications to identify if it carries these symptoms? So let's quickly again switch back to the console and ask Ocular if this code snippet carries these conditions. So again, I use the same nomenclature in Ocular where I ask what is the source. In this case, the source is an HTTP endpoint, which is accepting either a GET or a POST request. The sink in this case is a database because we are looking up a database. We are identifying the associated transaction ID and then reflecting back that information to the browser. And then we're adding one more nugget to this investigation, which is condition. Because in this workflow, we are asking whether if a request is initiated, is it being redirected to a login page so that the user logs in, validates his or her session, and then he or she are redirected to see their order details. Again, the results are returned, but it tells us that we are a request is initiated on an HTTP route, and there is a order ID which is fetched from either a GET or a POST attribute. And on that basis, we are looking up the database and reflecting back the results. So from this code snippet, it's pertinent that we are conducting a user role check, which is great because we asked for that condition. The other is, which is bad, is we are reflecting back the primary key from the database, which in effect means that this particular code snippet is susceptible to indirect object reference. So the results returned in this case is pretty printed, where you have the attribute which is tracked, the associated line number in your code base, and the file as well. Note that this information can be represented in JSON or any other format that fits your needs, so that you can take that information, serve it back to GitHub, Jira, or any other ticketing management system, so that your engineers can remediate this issue with sufficient guidance and narrative. So now I'm going to switch to another interesting use case, which is data privacy and compliance. All of us as we write applications, are dealing with sensitive information of our consumers. Usually we represent our consumers as user-defined types, which are models like type user, type customer, type account, etc. And then we correlate all of that and represent our customers as they come alive and they log in to our portals, help them serve their business needs, and after they log out, we destroy those objects. But as we begin to initialize these objects, as our customers interact with our web portals, sometimes we inadvertently leak these sensitive information or sensitive pieces of information either to third-party services if we are doing click track analytics, or perhaps we send it to a log file because we want to conduct more detailed debugging. In such cases, we are in complete violation of standards like GDPR, PCI, and SOC because we are treating our customer data in a very careless fashion. Because if any sensitive data is logged, that log is carried on via RSys log to your aggregation units like Splunk, Sumo Logic, or Elk Stack. And then your administrators can begin to sense and see sensitive data of your customers in clear text. If you're not conducting redaction obfuscation, even worse. This query leads to leaking of sensitive information, which further consequentially leads to account takeover. So how can we use Ocular to first of all identify sensitive units of information and thereafter ask if we are redacting, encrypting, or obfuscating these pieces of information before it's being sent off to a log file or perhaps a third-party service? So let us switch back to Ocular and ask these questions very quickly. Ocular provides a technology using natural language processing and machine learning to identify everything sensitive in your application. This technology is provided because Ocular has the capability of looking at how engineers name things in applications. You often define names, which is val user is equal to new user, or val social security number, or val SSN is equal to something. So Ocular has the capability of, first of all, identifying all variables, looking at these names, matching it against pre-canned dictionaries, which is derived from various compliance and regulatory institutions, and then scoring that element as sensitive. After that element is scored as sensitive, Ocular has the capability of following that element throughout all business workflows in your application to identify how it exits your application. In certain cases, it might exit the log. In certain cases, it might exit your HTTP channels to third-party service providers. So here we're asking a very simple question. We have a user-defined type of type user because it was deemed as sensitive, carrying credentials, PII, and location. And then we ask whether it exits on a sink of type logger. And then we further ask if this sensitive information is touching the sink without being obfuscated, redacted, or encrypted. So again, you get an entire flow trace. On quickly examining this flow trace, we see this object being initialized of type user and then touching this log file. But most importantly, if you pay attention to what is happening in between, it is evident that there is no encryption, redaction, or obfuscation, which squarely shows that we are leaking sensitive data on a channel that would lead to violation of compliance and possibly account takeover. Another case is, often there are exceptions that are thrown in our application. And if we carefully do not handle or catch these exceptions, they are reflected back in the browser. And if you pay attention to this exception that is reflected back in the browser, it provides interesting pieces or nuggets of information. Information like what type of database you use, what is your administrator login, what potentially is your server IP. If you're using an AWS, it might display your host name or perhaps your IP. And with this information, it enables an attacker to conduct reconnaissance so that they understand and characterize your application. And then as next steps, they begin to target attacks on your application in more creative ways. The other quick point that I want to draw out as use case is, we often hear of data breaches very often, literally on a weekly basis. So if we assume we are always at the risk of a data breach, the next question that we have to ask ourselves is, if a breach occurs, can we save ourselves from potentially an attacker unscrambling any encrypted data that is stored in that payload that has been breached, or that data archive that has been breached? So we have seen as evidence with some of the breaches that happened not too long ago with Sony, LinkedIn, House, etc., where a weak encryption or a weak crypto scheme was used, like DES, SHA-1, or Blowfish, in order to scramble passwords. So when a weak crypto is used, as a consequence after the breach, it makes it relatively easier for an attacker to use simple techniques like rainbow tables or allocate few CPU hours to unscramble those passwords and consequently lead to account takeover from your customer's perspective. So Ocular provides this facility to ask questions over all your applications of whether you're using a weak crypto. And if so, you can use that piece of information to fail the build and set forth a standard so that no engineer is essentially encrypting data using a weak crypto. So that essentially ends the presentation. I would encourage the audience to try Ocular on your code. We provide a 14-day free Ocular trial. And currently the trial supports Java only. And the trial version is not full-featured. If you wish to participate in a full-featured trial, please contact sales@shiftleft.io. And Ocular currently supports Java, C, C++, and C#. And along with the trial, we provide support, professional services, and training as well. It's relatively easy to bootstrap yourself on Ocular. It takes less than a few hours to learn the language and become productive. So I would really encourage everyone to visit the website, check out some material, and try Ocular. Thank you very much for taking your time, and I'm happy to take questions.
Great, thank you so much. We do have a few questions that have come in. The first question that we have is, we have custom sanitization steps on many of our routes with critical data. Will this tool be able to understand them so as not to create false positives?
Absolutely. What we provide to you is a series of runbooks, something that we have learned across different industry verticals so that you derive instant value as you procure Ocular. But besides that, if you have a specific business rule pertinent to your business line, it's relatively easier to tune and create a new policy to make those relevant checks specific to your business rule. That way, you get results which are very precise, and that in turn thwarts the false positives as well.
Great. Next question that we have is, can you help me find CVE variant vulnerables in my open source libraries?
Absolutely, yes. Like I demonstrated, in this presentation, Ocular understands the entire software composition of your application, which is all the open source that you use and the framework, which potentially could be open source upon which it is deployed. Any of these components could have CVEs, and if they do, it is also important to know if any of those CVEs can it be contextually triggered by an attacker? Meaning, do you have symptoms in your application that would lead for an attacker to traverse your application paths and touch that vulnerability? Given that Ocular has a very detailed understanding of your application, we provide contextual vulnerability analysis. So this is several levels in depth compared to any software composition analysis vendor, because we can very precisely tell you what needs to be fixed because you have symptoms in your code that would lead for that open source variant to be exploited.
Great. The next question that we have is, are there types of vulnerabilities that cannot be detected?
Yes, there are certain variants of vulnerabilities that cannot be detected, and those are associated with remote code injection. If your code is comprising of certain expression language or scripting capabilities and the necessary symptoms that would lead for a remote code to be sent to on a certain path, then that remote code snippet can be evaluated, compiled just in time. That would lead for this exploit to manifest. This typically happens if you're using reflection or if you have a JDK deployed where someone is abusing the compiler. And these types of attacks can only be understood if the runtime data is examined. But from an Ocular perspective, we can identify all the symptoms that exist, meaning are you using reflection? Are you parsing a certain code variant that is typically provided as a facility with an expression language? Symptomatically, if they exist, we'll tell you, but not precisely, because for remote code exploits, we have to understand runtime data as well, and Ocular is all about analyzing your code before it is deployed in production.
Great. The next question that we have is, does Shift Left have professional services to help me write my own custom queries?
Absolutely. We have experts in various business domains, those who have participated as ethical hackers, myself included. So we participate in a very deep professional services engagement to help you understand the issues that might lie in your business domain, and verification to see if rules can be created or policies can be created to ensure that these business criteria is not violated.
Great. The next question that we have is how your product is well updated with NVD and with fixes that which version of the open source API is not vulnerable?
Yes, I mean that specific to that question, given that we understand the entire software composition, meaning how your application is using open source, we can very precisely tell you whether a vulnerable open source library that you're using can be exploited or not. This is a huge benefit as compared to other software composition analysis vendors, because these vendors only look at your dependencies, compare it against CVE databases, which is the threat landscape, and let you know whether any inherent CVE exists for those vulnerable components. In our case, we identify that as well, but we also tell you whether you have a certain path in your code that would lead for that vulnerability to be triggered. With this, your engineers do not have to waste time upgrading the libraries. They can only choose to upgrade it if the necessary symptoms exist around that open source vulnerability.
Great. Looks like we have time for one more question, and that question is, we are looking for regression testing. Can custom queries help this?
Absolutely. If you have a battery of test suites that you run against your application, some of them are focused on performance, some security, and some perhaps business logic flaws. So you can create a series of queries using Ocular, run them automatically in your CI pipeline to identify if it is violating that constraint. Because as your new versions of your code is created, you can use Ocular to understand violations from a regression perspective, meaning when it has a new feature that has been added causing regression from a fundamental behavior that you have defined architecturally.
And that does look like all the time that we do have for questions. So Chetan, is there anything you would like to add before I close things out?
Thank you very much for attending, and I encourage the audience to try Ocular on your own applications. Talk to us on the community channel, communicate with us on sales@shiftleft.io. We are here to help you improve your security efficacy.